Happy Friday, guys. So please go to page 257 in your math journals. And while you're going there, I'll tell you a little joke. So, why did someone have to take the cookies to the hospital? Because they're feeling crummy. There it is, feeling crummy. Alright, so again, we're still talking about our random numbers and equal, all those kinds of things. And what we're going to look here is kind of showing us different outcomes that can happen visually, which means by what you can see. So they're trying to use this concept of having a bunch of different paths that you can take that could give you multiple different outcomes. So kind of like when you're at the point here, you can choose which direction you want to go. It's equal. You can go the one to the far left, middle right, and far right. But then you kind of eventually branch out to other things, and they get dumped out into different rooms. So I'm going to try to help you understand this concept. It's really just breaking down numbers and knowing how to break them down evenly. So this first example is going to be somewhat tricky, but I think once you see it, you'll understand the idea. However, we'll take a look at the next example on your next page, and I want to help you through that process too. So what it says here, it says the diagram at the right shows a maze. A person walking through the maze does not know in advance how many paths there are or how they divide. Pretend that you are walking through the maze. Each time the path divides, you select your next path at random. Each path at an intersection has the same chance of being selected. You may not retrace your steps. It means you can't go back. Depending on which paths you follow, you will end up in room A or room B. So, which one are you most likely to end up in? Well, which one has more paths dumping into it? So if I look at right here, we could take this path, and no matter what, if you take this left path, you're going in room B. No matter what, if you take the right path, you're going in room B. Oh, not really. There's another input right here, so that's not true. So we have 3 inputs for room B, and we have 1, 2, 3, 4, 5 for room A. So which one do you think you're more likely to end up in? A or B? I say A. There's more inputs there. You got a better chance because if you choose this left path, for sure you're going to end up in B. But if you take any of these others, there's a greater chance you can end up in A. Alright, so here we go. So suppose 80 people took turns walking through the maze. About how many people would you expect to end up in room A? So here's how we're writing it in. We're filling in this chart right here. We start out with 80 people. So how many people do you think out of 80 are going to end up in A? Well, here's the thing that I'm going off of. I'm going off by all these outputs. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 outputs, and there are 5 outputs into room A. So that's 5 out of 8. So I'm going to say that out of 80, I think about 50. Because see how we're doing like 5 to 8, and we're comparing it 80, just multiply them by 10. So then I expect that 30 will go into room B. Okay? So here's how we're going to complete our chart and the directions that can follow. So we start out with 80 people, and what we have to do is we have to divide it equally in these 4 boxes. So what's 80 divided by 4? Well, I know 8 divided by 4 is 2. Just throw in another 0, and I've got 20, 20, 20, 20, and 20. Very good. Alright, now we need to we can even go further. You see there's B's and A's, A, and then a B. So we plug in, again, we divide it equally. We see how we have 2 lines going into 20. Those need to be divided equally. So 20 divided by 2 is 10. So we have 10 here, 10 here, 10 all across the bottom. And this just proves our fact about my guesses up here. It's what we're expecting. Kind of like when you flip a coin, you can guess that it's 50-50, but as you guys noticed when you were doing your practices yesterday, it wasn't exactly 50-50. They're pretty close, but not very exact. So if we add these up, I have 10, 20, 30, and I have 10, 20, 30, 40, 50 right there. So we're just giving ourselves something written, something that we can see, which can help us understand the concept of probability and chance. Okay, let's take a look at the next page. Hopefully you're following me. Unfortunately, you can't tell me to slow down because you're watching on a video, but you can always rewind it. So here we have a couple other maze problems. But I need to point out to you a few things. Make sure that you divide them equally. So for example, you need to start out with the correct number. So here we're dealing with 60. Why is it not? I just aligned it. Come on. So that's a 60. So you can see that we divide that by 2, but when you get to the next step, one of them is divided by 3. So you need to be careful about that. Also, when you're looking at this problem down here, you have the same problem. Make sure you watch exactly where your trails go and that you're dividing them up equally. So I'll give you a little hint right here. We're dealing with 120. Maybe it's just that spot. That was really right on, 120. And we can divide it equally there, but you see this line here? Make sure that these are the same. If you notice, even though this B is on the same level as these, it's connected to this box, so it kind of skips a step. So be cautious about that. You'll see that over here on the same side. Remember that you need to divide them equally. Things to keep an eye out for. Okay, if you have any further questions, please ask me for help. The rest of your time today for math will be kind of making up your Excel worksheet, your mountain math. Make sure you get some of those worksheets on the table completed as well. And, as always, work hard. Remember, Nato is thinking and watching. He's holding you guys accountable. He wants to hear a good report when he comes back next week. Alright, guys. I will see you in real life.